According to theory, the surface of the Earth is broken into large pieces called plates. These plates float over an inner molten layer. The size and position of these plates change over time. An example of such movement is the idea of a supercontinent called Pangaea that existed millions of years ago. Evidence suggests that the separate continents we know today migrated from this one large landmass. The edges of these plates are sites of intense geological activity. Earthquakes, volcanoes, and mountain building can occur when they move against each other. Plate tectonics are a combination of two earlier ideas, continental drift and seafloor spreading. Continental drift is the movement of continents over the Earth's surface and their change in position relative to each other. Seafloor spreading is the creation of new oceanic crust at the mid-ocean ridge. Many changes and movements in the Earth's crust originate along lithospheric plate boundaries. Plate boundaries can be in the middle of the ocean floor, around the edges of continents, or within continents. There are several types of plate boundaries, each of which is associated with a characteristic type of geologic activity. Divergent boundaries are two plates moving apart from each other. Also known as spreading boundary, a divergent boundary occurs where two plates move apart, allowing magma or molten rock to rise from the Earth's interior to fill in the gap. The process by which the plates move apart can also be referred to as seafloor spreading. At this type of boundary, new oceanic crust is formed in the gap between two divergent plates. Plate area is increased as the plates move apart. Plate movements take place laterally away from the plate boundary, which is normally marked by a rise or a ridge. The ridge or rise may be offset by a transform fault. Presently, most divergent margins occur along the central zone of the world's major ocean basins. The Mid-Atlantic Ridge and East Pacific Rise provide good examples of this type of plate margin. Convergent boundaries are the direct collision of one plate with another. As seafloor spreading pulls plates apart at one boundary, those plates push into neighboring plates at other boundaries. The direct collision of one plate with another type of plate is called the convergent boundary. Three types of collisions can occur at convergent boundaries. Oceanic continental conversions. One type occurs when a plate with oceanic crust at its leading edge collides with a plate with continental crust at its edge. Because oceanic crust is denser, it is subducted, or first under the less dense continental crust. Scientists refer to the region along a plate boundary where one plate moves under another plate as a subduction zone. A deep oceanic trench generally forms along a subduction zone. As the oceanic plate moves down into a subduction zone, it melts and becomes part of the mantle material. Some of the magma formed rises to the surface through the continental crust and produces volcanic mountains. Continent-continent convergence. A second type of collision occurs when two plates with continental crust at their leading edges come together. During this type of collision, neither plate is conducted because they both have the same density. Instead, the colliding edges are crumpled and uplifted, producing a large mountain range. Scientists are convinced that the Himalayas were formed by this type of collision. Oceanic-oceanic convergence. The third type of collision along convergent boundaries occurs between oceanic crust and oceanic crust. A deep ocean trench also forms when one of these plates is subducted. Part of the subducted plate melts, and the resulting molten rock rise to the surface along the trench to form a chain of volcanic islands called an island arc. Transform fault boundaries occur where two plates are grinding past each other. Transform boundaries neither create nor consume crust. Rather, two plates move against each other, building up tension, and then releasing the tension in a sudden and often violent jerk. This sudden jerk creates an earthquake. The San Andreas Fault is undoubtedly the most famous transform boundary in the world. To the west of the fault is the Pacific Plate, which is moving northwest. To the east is the North American Plate, which is moving southeast. Los Angeles, located on the Pacific Plate, is now 340 miles south of San Francisco, located on the North American Plate. In 16 million years, the plates will have moved so much that Los Angeles will be north of San Francisco.